Okay, class, I'm going to make this video. This is how I'm going to try to teach these lessons on balancing chemical equations. And the good news for those of you that have gotten used to traveling through the modules and kind of learning and watching my little videos, you'll be in good shape. You'll know how to do this. For those people who have not yet figured out this semester that that's the best source of information for learning the material that we're covering, they're in a little bit of trouble because this is the only way you're going to get this stuff. So anyway, here's today's lesson. For starters, balancing chemical equations, you have to be mindful of the law of conservation of mass, which we've learned about during the first part of this unit. The law of conservation of mass simply states that whatever is in the reactant side absolutely has to be on the product side in terms of mass. So the example that I gave in an earlier video was that if we had a pile of firewood, and let's say we found the mass of that firewood to be 8 kilograms, and then we light it on fire. And we light that firewood on fire. When we're done, after all is said and done, and that fire has finished burning, we can go gather all the soot and the ash and then all the smoke. If we were able to capture it before it went up into the atmosphere, it should have an exact mass of 8 kilograms. Okay? The law of conservation of mass means that mass cannot be created or destroyed. So you're not going to gain mass, you're not going to lose mass through a chemical reaction. Okay? Now, that's a big deal when we're balancing chemical equations, which is the thing that we're going to learn to do now. And when you're balancing chemical equations, you're going to see chemical equations that are not balanced. Okay, they don't have the correct number of atoms on either side. And you're going to have to figure out how to balance them. Before we proceed, there's a couple of rules that are kind of musts, and I would write these down in my notes. Okay. One of those rules is that you treat polyatomic ions that don't get broken like just one element. Now let me show you what I mean. If you have a chemical reaction, okay, you're going to have the reactants over here and the products over here. If you have something like, say, sulfate, if you have sulfate on this side and you look over here and you see that sulfate never got broken, it's still over here on this side, just treat it the same way that you would an element like lithium. Okay? So for example, if there happens to be 2 sulfates, then you're going to need to figure out a way to have 2 sulfates over here. And we'll get into that. Okay, so that's rule number 1. Treat polyatomic ions that don't get broken as if they're just one element. We'll come back to that rule when we come to it so that it makes more sense. Another rule, don't go stuffing coefficients in the middle of molecules. So for example, if we have, let's say, lithium hydroxide. Oops, there shouldn't be a parentheses there, I'm sorry, but I'll put one in there anyway. Let's say we have lithium hydroxide, all right? You can't stick a coefficient in the middle, like right there, okay? The only place you could put it is at the beginning, like this. Okay, you can put a coefficient here, but you can't put it in the middle. You couldn't go putting a 2 here. All right? So don't go busting up molecules by putting a coefficient in the middle. That's a no-no. All right? There will be some other rules probably, but anyway, at the end, you have to count your elements and make sure you have the same on the left as you have on the right. Okay, so we're going to start with some unbalanced chemical reactions, and we're going to balance them. Okay. So let's start with this first one. And let's try to figure out what is unbalanced about it. Now, granted, you've got my handwriting, so just remember that this little thing right here, that's supposed to be an AQ for aqueous, AQ for aqueous, S for solid, and I think G for gas. It's pretty bad handwriting, but you get the point. Okay, now let's look at what's unbalanced about this chemical reaction. First, let's start by counting elements on both sides. All right, so we got one barium and one barium. So far, so good. We have one nitrate and one nitrate. So far, so good. We have two potassiums and one potassium. Uh-oh, that's going to be a problem. Okay, we have one sulfate and one sulfate. All right, so first let's start by doing something easy and following all the rules. Let's just put the coefficient 2 in front of potassium right here. Okay. Now, you guys know from math the distributive property. So when I put a 2 right here in front of potassium, that also means that that 2 applies to nitrate. So now I have two nitrates over here. Okay. Which means that I would have to put a 2 in front of this. Which means that I would have to put a 2 in front of this. Okay. So balancing chemical reactions. Let's try one that's a little bit easier. Okay. I forgot rule number 3, and I'm going to write rule number 3 down. Okay. Rule number 3 is use a pencil. Because you can erase a pencil. And when you're balancing chemical reactions, you definitely want to use something that you can erase. Now I'm using a pen so that it shows up really good in this video. But you want to use a pencil. Okay, let's start again by counting elements. One barium. Now does sulfate get busted up? It does. Sulfate gets busted up. So we can't count it the way we would a polyatomic ion. So one sulfur and 4 oxygens, one carbon. How about over here? We've got one barium, one sulfur, one carbon, and one oxygen. Okay, so the most glaring problem I see initially is that there's 4 oxygens here and only 1 here. So let's just see, if we were using a pencil, we wouldn't have to worry about scribbling stuff out. But let's see what would happen if I put a 4 right here. And if it doesn't work, I'll have to scribble it out because I wasn't smart enough to use a pencil. Okay, now let's start our count over. One barium, one sulfur, 4 oxygens, 4 oxygens. Change that to a 4. Cool. One carbon, 4 carbons. Uh-oh, got to add a 4 here. That changes that to a 4. Now let's check. One barium, one sulfur, 4 oxygens, 4 carbons. And that is a balanced chemical reaction. Let's do another one. By the way, you guys can always pause this if I'm going too fast. You can't say, Mr. Olive goes so fast I can't keep up with him, because, hey, you have control. Just move your mouse, right? Okay. Let's try this one. Or I guess you guys are using Chromebooks, no mice. Okay, let's see if this is even balanced. For starters, this is a liquid, this is a liquid, this is a gas. Okay, so how many aluminums? 2. How about over here? 1. Ooh. How many oxygens here? 3. How about here? 2. Okay, so totally unbalanced. So let's start by using some intuition here. Let's see. What's 2 and 3? What is it? Greatest common factor or least common multiple? Whatever 6 is, that's what I want to turn this 3 and this 2 in, because that's the lowest place where they meet. So I'm going to put a 3 here so that I have 6 oxygens. And I'm going to put a 2 here so that I have 6 oxygens. And let's see what that did for my aluminum. Now I have 4 aluminums and 1 aluminum. Easy fix. Just put a 4 right there. Okay, 4 aluminums, 6 oxygens, 6 oxygens. Cool. Let's do another one. Okay, step 1, and you can pause it on this one. What is wrong with this? Is it balanced? Okay, you've got hydrogen gas, oxygen gas becomes H2O2, which also ends up being a gas. Okay, so, or no, H2O. So we have an unbalanced equation because we only have 1 oxygen on this side. Okay, so give you a minute. Go ahead and pause it and see if you can balance it before I do. See if you can fix the fact that there's 1 oxygen on one side and 2 on the other. Pause it. Okay, good. Did you get it? All right, well, let's find out if you did. I'm going to put a 2 here, which gives me 2 oxygens, but 4 hydrogens, and I'll put a 2 here. Now I have 4 hydrogens, 2 oxygens, 2 oxygens. Okay, let's try this one. Okay, this is remember this is what's called a decomposition reaction. The other one was called a synthesis reaction. This one's called a decomposition reaction. Try this one that's under my paper here. H2O becomes hydrogen gas and oxygen gas. See if you can balance it. Okay, the first problem I see, go ahead and pause it and see if you can beat me to it. Here, let me hold this so that it's easier to focus on. Okay. Now we're good. Okay. So, what's the problem? First, determine the problem. Pause it and see if you can determine the problem before I do. Okay. So, if you determined the problem by pausing it, you would have realized that there's 2 oxygens here and only 1 here. So let's first by seeing if we can solve that. Let's just go a 2 here, coefficient here. We took care of the oxygen problem, but we created a hydrogen problem. We have 4 hydrogens here and 2 here. So see if you can solve that problem. Okay, if you did that right, you did this. Okay, you're gonna have to be quick to pause this and beat me to it. Okay, so that you know that you're getting this right. And then you can always just check your work. It's the best way to learn. See if you can challenge yourself to do these before I do them. Okay? Best way to learn. All right. And if it seems like I'm going too fast, it's not. It's because you're not pausing it. So it's your fault, not mine. Nana, nana, nana. Okay, here we go. We got copper, which is a solid here. Copper plus silver nitrate becomes copper nitrate and silver. Silver is a solid here. So this is a single displacement. Remember those? Single displacement. Okay, let's start by counting stuff up here. 1 copper, 1 copper, 1 silver, 1 silver, 1 nitrate. I can count that as just 1 element because it doesn't get split. 2 nitrates. All right. So let's balance it. First thing I got to do is take care of this nitrate over here. So pause it. You fix it. Okay. So this is what I would have done. I would have put a coefficient of 2 right here. And then I also have to take care of my silver discrepancy because now I have 2 of those. 2 of those. So I'm going to put a 2 right here. And that changes that to a 2. And I'm balanced. 1 copper, 1 copper, 2 silvers, 2 silvers, 2 nitrates, 2 nitrates. You guys are doing awesome. Super good. Super awesome. Super good. We'll make another video and we'll practice a few more.